Hello, my dear children, and welcome back. I know. Board exams are just around the corner, and the tension is building up, right? And then you see a chapter called linear programming, and your heart just sinks a little bit. Oh God, another difficult math chapter. But wait, what if I told you this is actually a secret scoring chapter? It's true. Trust me, after this, you're not just going to understand it, you're going to master it and get full marks. Let's make this your secret weapon for the exam.
Okay, Chalo, let's dive right in. Forget all the scary math formulas for a second. Just think of linear programming as a game, a puzzle, a real-life puzzle about how to make the most money. I mean, who doesn't like that idea, huh? So just imagine this. You have a little bit of money, and you have a small shop. Now, what do you fill your shop with to make the absolute maximum profit? Should you buy this or that? How many of each? That, my friends, is the exact question linear programming helps us answer. And we're going to crack it together. Okay, so to make this super easy and fun, let's meet a friend of ours. His name is Raju, and he's a furniture dealer. And well, Raju has a bit of a problem. A puzzle, really. And he's asked us for help. So what do you say? Let's become business consultants for a day and help Raju out. So here's the deal with Raju. First, he has 50,000 rupees to invest. That's his entire budget. Second, his storage space, his godown, is kind of small. It can only hold 60 items in total, not one more. And finally, he only deals in two things, tables and chairs. That's it. Simple, right? All right, now this is where the real puzzle begins. Look at this. A table costs him 2,500 rupees, but hey, it gives a nice profit of 250. On the other hand, a chair is much cheaper, just 500 rupees, but the profit is smaller too, only 75. So what should he do? Should he buy a few expensive tables for a big profit per piece, or should he buy lots of cheaper chairs for a smaller profit per piece? This is the real question, isn't it? Okay, so we totally get Raju's problem now, right? It's a business problem. But this is a math class, so it's time to put on our math hats. We're going to take this simple story and translate it word for word into the language of math. And please, don't worry, it's going to be so simple. I'll show you. So first things first, what are the two things we actually need to decide for Raju? Simple. The number of tables he should buy and the number of chairs. That's all. In math, we give these unknown things a special name, decision variables. So let's just say the number of tables is X and the number of chairs is Y. As simple as that. Okay, now what is our main mission? What is the goal? It's to make Raju's profit maximum, right? We want him to earn as much as possible. This main goal is what we call our objective function. So think about it. If one table gives 250 rupees profit, X tables will give 250 times X. And if one chair gives 75 rupees profit, Y chairs will give 75 times Y. So the total profit, let's call it Z, is just 250X plus 75Y. Our whole mission is to make this Z as big as possible. But wait a minute, can Raju just buy an infinite number of tables and chairs? No way! He has rules he has to follow, right? He has limits. It's like when your parents give you a budget, or in a game you have limited lives. In math, we call these limits or rules constraints. And for Raju, what are the two big constraints? His money and his space. So let's write these rules down in math. First, the money rule. Each table costs 2,500, so X tables cost 2,500X. Each chair costs 500, so Y chairs cost 500Y. The total cost has to be less than or equal to his budget of 50,000. Next, the space rule. The number of tables, X, plus the number of chairs, Y, has to be less than or equal to the 60 items he can store. And finally, the common sense rule. You can't buy -5 tables, right? So obviously, X and Y have to be 0 or more. We call these the non-negative constraints. All right, we've done the hard part. We have our objective, we have our rules, all in math language. Now for the fun part, the visual part. We're literally going to draw a map of every single possible solution for Raju. It's like a treasure map, and the treasure is the maximum profit. You remember those rules, those inequalities we just wrote? Well, each one of them is going to become a line on our graph. These lines are going to form the boundaries, like the fences around a field. And inside that field is where all our answers are. And ta-da! Here it is. See this shaded area? This is our magic zone. We call it the feasible region. Think of it like a playground. Any point inside this shaded area is a combination of tables and chairs that Raju can actually buy without breaking his rules. But look how many points there are. Infinite points. How on earth do we find the one single point that gives the biggest profit? So the big question is, do we have to check every single point inside that huge area? That would take forever. But no, we don't have to, because I'm about to tell you a secret, a super powerful shortcut, a magic trick that makes this whole chapter so easy. And here is the secret. Listen carefully. The best answer, the maximum profit, or even the minimum cost, it's always hiding at one of the corner points of that shaded area. Always. Why? Because to get the maximum profit, you have to use your money and space to the absolute limit, right? And where are the limits? The lines. And where do the lines meet? At the corners. So the best answer has to be at one of the corners. This is the golden rule of this chapter. This amazing trick is called the corner point method. And it's just a simple 4-step recipe. Step 1, draw the graph and find the shaded feasible region. Step 2, find the coordinates of all the corner points. Step 3, put each corner point into our profit formula Z. And step 4, whichever point gives the highest value for Z, that's your answer. That's it. It's that simple. Okay, let's use this method for Raju's problem right now. Let's check the corners. At corner O, that's 0, 0. Obviously, the profit is 0. At corner A, the profit is 5,000 rupees. At corner C, it's 4,500. Okay, and now the last corner, point B. When we put in 10 tables and 50 chairs, the profit is, drumroll please, 6,250 rupees. That's the highest number. We found it. So there you have it. We've solved Raju's big business puzzle. The maximum profit he can make is 6,250 rupees, and to do that, he must buy exactly 10 tables and 50 chairs. See, I told you it was easy. You just have to find the corners and check them. That's the whole game. Feeling confident? You should be. You're already a pro at this. So how about we try a proper exam question now, just to prove to yourself that you can handle anything they throw at you. Ready? Let's do it. Okay, here's a typical question you might see in your board exam. Maximize z equals 4x plus y. And these are your constraints. X plus y is less than or equal to 50, and 3x plus y is less than or equal to 90. So what's the first step? Come on, you know this. Yes, we draw the graph. Okay, so first we draw our lines for the two constraints. We shade the common area to get our feasible region. Now let's find the corners. We have O, A, B, and C. O is, of course, 0, 0. A and C are on the axes, so that's easy to find. Now what about B? Point B is where the two lines cross. So how do you find it? You just solve the two equations simultaneously, like you learned in class 10. Once we have all 4 corner points, it's time for the final step, testing them in our Z formula. And the answer is 120. The maximum value of Z is 120, and it happens at the point 30, 0. You did it. See, you just solved a board exam question. It's exactly the same process every single time. You guys are amazing, seriously. All right, before we finish, let me give you a final exam day checklist, a super simple summary that you can keep in your mind. This will make sure you never get stuck on a linear programming problem. Just remember these 4 magic steps. First, formulate. That means write down your Z and your constraints. Second, draw. Draw the graph and find the feasible region. Third, identify. Find all the corner points. And fourth, calculate. Check the value of Z at each corner to find your final answer. That's it, the whole chapter in just 4 words. So you see, you now have a problem-solving superpower. You can use this for so many things, not just for your exams. But for now, focus on acing that paper. I really hope this has made things super simple and clear. All the best, my dear children. Go into that exam hall with confidence. You've got this. Study well, and I'll see you next time. Bye-bye.